is your topic game theory of your operation search. So few definition we may use here is your competitive game. That means both the opponent are competitor are very strong with each other. It is not one-sided kind of the game, right? So zero sum here. Zero sum says that the profit of one player is a loss of others. If more than one player we have, so that we may say total profit and loss in that game should be equal to zero. So then that game is called your zero sum game. If your profit and loss have the little different than zero, then it is called non-zero sum game. Strategy. Strategy means your once your one player uh, choose your one step or one your strategy, and opposite to that another player have also choose your have the more than one option in their planning, but he may choose particular strategy is called your two type of these we have. One is your pure means when you choose your strategy and you choose your steps, so opposite to that another player have the fixed number of chances that he can choose this one, right? So that is called the pure kind, in which you know that once you choose your this step, your opponent choose this particular step only, that clearly known to us, that is called the pure strategy, right? And we always try for the maximizing the gain. And mixed strategy means when you choose your step, then your opponent have many options, but there are some probability of choosing these options. Because here probability is involved, so it is called the mixed strategy. One then more option he or she or your opponent has, which is depending upon the probability and situation he can opt. And here also we maximize the gain, right? So particular we discuss here your two player zero sum. So two player means we have only two players, right? So game with only two player is called two person game or two player game. Zero sum means if you the loss of one player are equivalent to your gain of your other player, so that the sum of net gain, or you say payoff, this gain is also called your payoff, is your always zero. So in zero sum game your sum of net gain is your zero. So what is your payoff matrix? A matrix is always given to us which shows your payoff matrix, which show the player A and your player B. Here suppose this in this matrix, this payoff value is your V11. That means when your player A choose your first strategy, in the against player B also choose your first one, then payoff value is your V11. But if player B choose your second, then its payoff value is your 1-2 against your first strategy of your player A. Similarly, this matrix we have. For example, for ith strategy of your player A, player B can choose your first, then its value is Vi1. Similarly, if player B choose second, its value is your Vi2. So another important thing here, this show the payoff matrix of player A only. If we talking about the player payoff matrix of player B, we just change the sign of your payoff values, either like V1, V2, V13 like this. We just change the sign of these. That means if this is positive for player A, so this should be a loss for player B or vice versa, because we know that we are talking about the zero sum game, so profit and loss should be Same. So optimal strategy, we are always go for the optimal value. We try to maximize the gain for player A always. So we solve the game whose payoff matrix is given here. This is example. So this is a player A and suppose this is your player B. So player A has three options. Similarly, player B has three options. So 3 into 3, we have the 9 options, and corresponding payoff values are given in this payoff matrix. So first of all, you can write this matrix in this way. Your B is this side, A is this side, and here we say row minimum. Row minimum means we just choose the minimum of this first row. So minimum of this first row is your -3. So we write here. Minimum of second row is your 0. Minimum of your last row is your -4. So in first step, we can write the minimum of your each row. Similarly, column wise, we write the maximum of column. In row, we write the minimum values. In column, we write the maximum value. So maximum of first row is your 5 here. Second row, it is 0. Third row, it is your 2. Once you calculate the minimum of your each row and your maximum of your each column, now you choose the maximum value from all these minimum. So maximum of all these minimum. So one calculated row wise minimum. Now choose the maximum of these three. That is -3, 0, -4. We know that 0 is your that maximum. Similarly, we can calculate the minimum of all these maximum column wise. So column wise, we already write here your maximum values. So now choose the minimum out of these. So that is minimum of maximum value. So that is again 502. Minimum is your 0. So this can be represented by min maximum value can be represented by V upper bar. So this is V with your upper bar, and this max min value can be represented by V lower bar. We just check the here it is lower value, then we go for the maximum. Here we have the column wise maximum value, then we go for the minimum. So these two should be same. So here if you see, we check the maximum of all these rows, that is 0, minimum of these columns, that value of game. So this particular is called the value of game. Another way we have what you can do, you can choose here row wise your minimum value. If you see, the minimum of this row can be here and here also. You can choose any one of them, as both are same. Now second row minimum is your this 0. Third row is your this -4. This is another way to get your result. Now column wise maximum is your this one. Write this in your box. Second column maximum is your this one. Third column maximum is this one. So if you see here, this at this position, your position here A22, here this minimum of row wise and maximum of column wise your coincide. That is called your saddle point, or that is called your value of game, that we already say here. You may find row wise minimum then maximum, and column wise maximum then minimum is 0. So that is this one. You can try by this form also, this way also. So this is called your value of this game. So value of this game is at location A22. So this 22 means your player A choose your second strategy, against that player B also choose your second strategy. So this 22 is called your coincide point. That's why it is called your saddle point. So optimal at this situation, your optimal strategy for player A is your this one A2. So similarly, optimal strategy against that player B is your also A2. This we get from this, as we get the this as your settle point. So location is second row and second column. So optimal strategy for player A is also second, or player B is also second. And value of game, that the value of this location is called your value of game, that is 0 in this particular example. So I use here a few definition like your saddle point. So saddle points is a point where we understand here the maximum of row wise minimum and minimum of row wise maximum, column wise maximum coincide. So by definition, the saddle point of payoff matrix is the position of such an element in a payoff matrix which is minimum in its row and maximum in its column. So that is max min, or you say min max. Optimal strategy, we already say the optimal value. If a payoff matrix has saddle point at RS position, so for player A, this R is your optimal strategy, and for player B, this S is your optimal strategy, right? And value of game, when your this max min and min max are equal, so this particular value is called your value of game. Or also, if your this min max and max min is equal to 0, then game is called your fair game. So we may go for more examples. So you just choose here minimum element row wise. So this 2 is minimum in this, 7 in second column row, sorry, and 4 in your last row. So column wise maximum you can choose. So 10 is maximum here, 7 is maximum here, and 9 is maximum here. So if you see here again at this 2 location, minimum and maximum are coincides. So this is called the saddle point, and the optimal strategy for player A is your this second step, that is A2, and for against that player B is also optimal strategy is your B2. And we may say your what is your value of game, value of game. So value of game is your this value at this location, 2 location, that is your 7. So simple one. So you may write here strategy of player A is your A2, for B is your B2, and value of game is your 7. So another example we may have, the minimum element in first row is your -2, and here second row it is 1, third row it is -4, fourth row it is -6. So column wise maximum is your 5 here, 3, and this it is a 0. Here it is. Sorry, we may write this in a circle form. And here maximum is this, right? So in this game, if you see, this is the fair. Sorry, in this sorry. In this maximum is your this one is maximum. So here maximum is your 5, and here maximum is your 6. So if you see here, this is your coincide point, or you say saddle point. So optimal strategy for player A is your second, and optimal strategy for player B is your third, and value of game is your 1. So this is your value of game. This value is called your value of game. So one more example, if you want to try, the minimum of this row is your 1, and minimum of second row is your 5, sorry 4, and last row is your 0, and maximum is your 7 in first column, 7 in second column, and 4 is in your third column, 5 in last column. So if you see here at second row, third column, it is coincide. So this is a location of saddle point. A2 is your optimal strategy for player A, and B3 is your optimal strategy for player B, and the value of game is your 4 here. Now we may have the mixed strategy game. So mixed strategy game is your without saddle point. There is no saddle point there. So in that we can use the method that is called your algebraic methods. So what we do in that, we have two methods here. First is your algebraic. So first check here saddle point exists or not. If you see, the minimum of this first row is your 5, minimum of second row is your 10, maximum of first column is your 25, maximum of second column is your 15. So if you say no saddle point exists in this problem, so if no saddle point is exist in the problem, this is your mixed strategy. Mixed strategy means it depending upon the probabilities. So in that case, we may write here in the probability P, and you know that total probability of system is your 1 always. So the probability of this is your 1 minus P, and in against B we assume probability is Q, and B2 probability is your 1 minus Q, because total probability is your 1 always. Now you just multiply this 25 with your P and 10 with your 1 minus P, and we get 25P plus 10 1 minus P. Similarly, you can multiply this here 5 with your P and 15 with your 1 minus P. That is your 5P plus 15 1 minus P. We just equate these two values. This is called your expected value actually. So this is called the expected value of A, that is your these values, and multiply with the corresponding probability. So we just compare the expected value of your these two. So that give you a, if you solve these two, you see 25, 10 minus 10p, 5p, 15, and 15p with minus I. So once you solve this, this is your left side is your 15p, and here right side is your 10p. You just shift to that side, left side, that is your 25p, and right side we have your 15, and we shift this 10 to right hand side, that is minus 10. 15 minus 10 is your 5, and that give you a value of P, that is your 5 by 25, which is your 1 by 5. So P is your here 1 by 5, and obvious this 1 minus P is your 4 by 5. Similarly, you can multiply this your first row with your Q and 1 minus Q. That means 25 into Q plus 5 into 1 minus Q. And similarly, your 10 with Q and 15 with your 1 minus Q. After solving, you get the value of Q, that is your 2 by 5. And 1 minus Q is your 3 by 5. So once you do that, this is your the player A choose your A1 strategy, that probability is your 1 by 5, and if you choose your A2 strategy, probability is your 4 by 5. Similarly, your player B can choose your B1 strategy is your probability your 2 by 5, and B2 strategy is probability is your 3 by 5. So optimal strategy, we can write here both the probability, that is 1 by 5 comma 4 by 5, and optimal strategy for player B is your Q and 1 minus Q, right? So what is your value of game? Value of game is your expected payoff of your player A. That means here just this multiplication, that is 25 into P plus 10 into 1 minus P, this one, that is expected value. So 25 into P is your 1 by 5, and 10 into 1 minus Q, that is 4 by 5. So if you add, this is your 13. Similarly, you can check the value of game through the expected value of your player B, that is by 25 into Q, that is 2 by 5, 5 into 3 by 5, 1 minus Q. So if we add this, that is also 13. This should be 13 actually, because we know that this is zero sum game. So both the value should be same. So value of game is your 13. Or if you say this is for the player A, it is 13. For player B, you may say it is minus 13, right? So, but same thing, value of game is your 13. Another method we have, that is called the arithmetic method for the problem where we see your saddle point not reach or not get. So same example we are taking. So for this, you just needed to subtract these two value row wise. 25, that is maximum value, and minimum value you need to subtract. So that is 20 here, and 15 minus 10, that is your 5 here. Same thing you can do your column wise, that is 25 and 10, that is 15. 15 minus 5 is your 10. After getting these, you can just change their position. So you write 5 here and 25 here. Sorry, 20 here. Similarly, here also you can write 10 here and 15 here. After that, after interchanging, you add these two probabilities, that is your values, that is 5 and 25. So this 5 plus 20 is your 25. So you just divide this by 25 and also divide this by 25. So this is your 1 by 5 and this is your 4 by 5. So if you see in your previous method, we get the same value of this, that is probability, which is P 1 by 5, and 1 minus P here, that is your 4 by 5. You can check your previous, you may see here 1 by 5 and 4 by 5, which is same by your arithmetic method. So here also 10 plus 15 is add 25. So we add here 25. So here also we can divide, this is 25. So this is your 3 by 5. And here it is 2 by 5. We may check in algebraic method. So that is 2 by 5 and 3 by 5. So which is same. After getting these probability, you can these are the probabilities. Package remaining is same, that A1 strategy with probability or 1 by 5, B1 with probability 4 by 5. So we may say optimal strategy for player is your 1 by 5, comma your 4 by 5 for player A. And similarly, optimal strategy for player B is your 2 by 5 and 3 by 5. And for the value of game, you needed to calculate the expectation. So for your value of game, as we have already done, you just multiply this 25 with your 1 by 5 and 10 with your 4 5 and add this. So 25 into 1 by 5 is your 5 only, plus 10 into your 4 by 5, that is your 8. So value of game is here 30. So which is same we already discussed, right, in by algebraic method. So by algebraic and arithmetic method, these are the methods, right? Now we have important rule here, that is your principle of dominance to reduce the size of game. So if you see we not get the saddle point, that means value of game we are unable to find as in the normal procedures. So your arithmetic and algebraic method is applicable only for your 2 cross 2 matrix. Arithmetic and algebraic method is applicable for your 2 cross 2 matrix. So if your matrix is of higher order, then we should convert your matrix into a 2 cross 2 matrix, and to convert this we require your some rules. Those rules are called your principle of dominance, that help us to reduce the size of games. So if one pure strategy of player is better or superior than the another strategy, so obvious we prefer the better strategy. So there is no need of your inferior strategy. So in that case we can ignore your inferior strategy, right? So I'm saying here one option is better than other option. If so, so why we choose your lower options, inferior options? So that we not require the inferior option, so we can delete that particular row or columns, right? So in a first step, they say that if all the element in a row of payoff matrix are less than equal to corresponding element of another row, that means another row is your superior, because first chosen row, ith row, are inferior, having all value are less. In that case, we never choose the ith strategy because its all values are lower. So in that case, the jth row is dominating on your ith row, so we not require your lower one, right? So also we know that your all matrix is given with respect to player A, not for player B. So in second step, if you see here, if all the element in column, suppose jth column of a pair of matrix are greater than equal to the corresponding element of other. So here we think as per as your player A only. So then player B will never choose the strategy Rth strategy where your greater value is there. So in column we remove the column with greater values, and in row we remove the with your lower values, because we go the problem with your in flavor A payoff matrix accordingly, right? In other words, Rth strategy is dominating by the Sth, so we remove your Rth column in that case. So in row we remove the lower one, inferior one. In column we remove the superior one, because matrix is for the player A always given, right? We think about one side only, right? So for the player A strategy we can think. So pure strategy may be dominated if inferior to the average of two. So we also, if it may possible sometime, only one inferior not there. So in that case, if we can use the strategy may be dominated if inferior to average of two in row or more other pure strategy. So in it say that we can use the average of two rows also. So pure strategy may be dominated if it is inferior the average of other two. In that case we also prefer, or more than pure strategy, right? So this is your third step. So we can go with the examples in this. And one important point, we use the dominance only when your saddle point does not exist, and this help us to convert your matrix into 2 cross 2 matrix, so that we can apply your algebraic and arithmetic methods. So one example we can go through in a short. So this is payoff matrix. If you see in a first row, we have one is your least element, minimum value. In second, two is minimum value. In third, two is minimum value. In first column, your six is your maximum value. In second, your seven is your maximum value. In third, seven is your maximum value. If you see, there is no saddle point here. So if you know saddle point, you use the principle of dominance. What principle dominance says? Principle of dominance say you check the row wise, any row having all element less than equal to your any particular row, then the row with your lower elements we can remove. So if you see here, second row and third row, your this 6 is 5 is your lower than 6, these two are equal, so 6 is lower than your 7, so we may remove your this particular third row. So first you can check row wise, then you can again check row wise. Here if you say here 1 is lower than 6 but 7 is higher than 6, greater value, so we can again not able to use row wise, so you can think column wise. So if you see column wise here, this 1 is less than this 2, 6 is less than this 7. In column you remove the higher matrix, not right. So in this you can remove the matter row or column. In row we use the row which is having all element are lower but less or inferior, but in column we remove all with having superior values or greater values, so we remove this one. Now we have 2 cross 2 matrix only. So in 2 cross 2 matrix we know that very simple, we take the difference of these two. Difference of 7 and 1 is your 6. Difference of 6 and 2 is your 4. That here also difference 6 and 1 is your 5. 7 and 2 is your 5. Now we just change the position of these two. Here we write your 4. Here we write your 6. So here both are same, so no change if you change the position. Now we add these two, that is 10. So we divide this by 10. So probability is your 2 by 5 here. Here also we divide this by 10, so it is your 3 by 5. So similarly, this 5 plus 5 is 10, so we divide this by 10. So probability is your 1 by 2. Here divided by 10, that means probability is your 1 by 2. So after that, you see player A choose the optimal strategy, that is your this one. Your first option is your with probability 2 by 3. Second option is your probability 3 by 5. But your statement is given in your 3 row and 3 columns. So we must have one more strategy, that is your x3 or you say a3, but its value is your, as it is not in a table, so we can say that's probability is your 0 only. So similarly, probability, the player B optimal strategy probabilities are your first is your 1 by 2, second is your also 1 by 2, but third is not here in a table, so it is here with probability 0. So that is optimal strategy of player A and B. Similarly, you can calculate your value of game. So for that, you can just multiply this 1 with your 2 by 5 and 6 with your 3 by 5. So that is your 20 by 5 and that is 4. So value of game for player A to the player A is your 4, and if you want for player B it is minus 4, right? So I'm stopping here. Thank you very much. In the next lecture, we may discuss
Thank you,
one more
sir.
example on this. Okay, thank you so much.
Thank you, sir.